Hey there, it's Andrea with my week 7 advanced interactive concept. I'm going to be hopefully showing how to make ferrofluid out of printer toner. And since the only way I could get the toner was to actually break open a cartridge, that's what I did. So here I have, I'm just going to put up actually, some toner that I broke open from this Brother cartridge, and as you can see, it's in there. And then what I'm going to do is mix it with some vegetable oil, and let me see if I can set this up here. Okay, so what I'm going to do is put the toner in this cup right here. Made a little bit of a mess. Okay, and then I'm going to add some just regular vegetable oil and try to get it to be a very liquidy consistency. So I'm going to start with 1 tablespoon and 2 tablespoons. Oops, that was a little bit much, but hopefully it'll be okay. Mix it up. Oh my gosh, I'm making a mess. Okay, that looks pretty liquidy. I think it'll be okay. I'm actually going to test it out first in the cup. So now I have my rare earth metal, magnet. I got from the hardware store. Just want to make sure that it's completely liquidy because it's kind of clumpy. Okay. Let's see if it works in here first. Not really. It's not working so far. Not in here. Let me go like this, actually. Like that? Like that? Nope. Nope. Okay. So, let me see if this works actually on the table. The only thing I'm thinking is that maybe that cup is maybe too thick. So I'm going to make my little makeshift table out of my box here. There you go. Yep. It's not working. Nothing. I'm going to put it right above there. I don't really see anything working at all. No spikes are forming. Okay. So I'll let it sit there for a second, see if anything happens, and kind of read off of my little speech here. So a ferrofluid is supposed to become magnetized in the presence of a magnetic field. So the spiky shape comes from the need to find the most stable shape in order to minimize the total energy of the system, which is known as the normal field instability. The fluid is more easily magnetized than the surrounding air, so it's drawn out along the magnetic field lines, resulting in the formation of peaks and troughs. So the extension of the ferrofluid is resisted by gravity and surface tension. The formation of the corrugations lowers the magnetic energy of the system, but raises the gravitational energy and surface free energy. So when these forces are balanced, the minimum energy configuration is achieved. Because ferrofluids are very easily magnetized, the peaks can be produced using a small bar magnet, which is what I have here. This magnet is supposed to pull about 25 pounds. So I don't think that it's the magnet. I think the reason why it didn't work is because the ferrofluid is usually supposed to be made of some sort of like iron oxide compound, and apparently the toner used to be made with those kinds of elements before, but apparently now the elements that they use to make toner are different. I think it's made more from plastic, so the plastics aren't going to react, and that's why I think that this didn't work. Um, but it should have, but it didn't. So I'll try it one more time. I thought maybe the barrier of the plastic or the box was kind of the problem, but yeah, nothing's happening. So I think it's just basically because toner is made from plastic nowadays, and there's no tiny little magnetic nanoparticles to react in the ferrofluid.